Hello. Here we'll wait for a minute. Students are joining. Hello. Good afternoon, everyone. In last lecture, we reviewed our first chapter, that is protective relays, and today we'll see the review of second chapter, that is over current protection and differential protection. So here, over current protection means here we are protecting or seeing the relays. If the current is more, then how to protect that by using different relays. And the differential protection means if any fault will occur at any side of the equipment, then how that equipment can be protected by using the differential protection, right? So we'll see these schemes here. So in this over current protection, first we'll see what is mean by fuse. uh, what are the fuse characteristics? All of you are familiar with the fuse, right? So what are different types of fuses? That is the rewirable and HRC fuse. Then fuse characteristic, it is nothing but the current time characteristic. Then application and selection of fuse. Then what is mean by this plug setting, time setting? It is important point because the examples can also be asked in examination on this PSM and the TSM, right? Then radial feeders and ring main protection and relay coordination. So these all are the basics. Then after that we'll see different types of relays, that is the earth fault, phase fault, directional static relay, microprocessor based overcurrent relay, numerical overcurrent relays, simple differential and percentage differential relay, and line protection. Okay, line protection. So we'll see one by one. First is the introduction to the fuse. So this is the fuse all of you have seen. And, so there are different types of fuses, but this fuse is nothing but one conductor, right? and it is placed or in between the circuit where and if the very high current will flow through that circuit, then it will melt, and in this way it breaks the circuit, right? So fuse is nothing but a short piece of metal which melts when the excessive current flows through it, and in this way it breaks the circuit, right? Now how actually this fuse works simply, here your load is considered, and when you are giving the supply, and if it is the normal operating condition, then the current will flow through the circuit. But if the overcurrent or a very high current will flow through the circuit, then the rated value of the fuse, that time this fuse will blow out, means its conductor will melt there. Okay, so this is the working of fuse. Okay, and here a short circuit is happened, that is one type of a fault. Okay, then there are different advantages of this fuses, that they are very cheap as compared to other elements, right? And main disadvantage is that we have to every time replace that fuse, means it is taking some time, right? uh, for rewiring and replacing. Then there are different types, that is two types here in your syllabus, that is the rewirable type, or it is also called KitKat type fuse, and second is the HRC, means high rupturing capacity fuses, right? So the rewirable fuses means which we are using at your home. So when where your main supply is came at your at your meter. Okay, so there is a fuse, that is rewirable fuse, or it is also called the KitKat fuse. Okay, KitKat fuse. And the HRC fuses, for HRC fuses you can take for example your stabilizer at your home, or any other some electronics equipments also. If you check that fuse, that is very small. Okay, and these are the HRC fuses. Okay, s- so these are the rewirable fuses shown here also. You can just remove this socket and replace the conductor in that fuse. Okay, uh, then HRC fuses. So these are the HRC fuses. Okay, so this can be used in many equipments. Okay, but they are having high rupturing capacity. Means the rating of the your KitKat fuse is low, but these fuses are high, highly rated. Means the ratings are more, and also they have high rupturing capacity. Means the faster operation. Okay, faster operation. Then these HRC fuses having some advantages, that is they do not deteriorate with age. With age means if you consider that KitKat fuse, then that conductor may get deteriorated. Okay, after long time. But for this fuse, that fuse, this HRC is packed. Okay, its conductor is packed, so it cannot deteriorate, and okay, then fusing operation is fast without noise and smoke. Okay, and there are some disadvantages of HRC fuses. That is, first is after each operation they have to be replaced, and heat being produced by arc may affect the associated switches. Okay, so these are the disadvantages. This is the disadvantage of your of every fuse. Okay, because we have to replace when the conductor will melt there. Okay, then the next point is important terms in this chapter. Hello. So important terms of fuse are: first is the current rating of fuse element, then second is fusing current and fusing factor. Okay, so all are related to fuses only. There are some more terms also. So current rating means what is the rating of that fuse. Okay, means what is the maximum value of current that can be passed through the fuse. Means, for example, if the fuse is of 10 ampere, means it can pass maximum 10 ampere current, right? And if the current flowing through that fuse is about 10 ampere, that fuse will melt there. Okay. uh, then fusing current means at which current that fuse will melt or that conductor will melt. That is nothing but fusing current. Then fusing factor, it is the ratio of minimum fusing current to current rating of the fuse. Means at what current that uh, fuse, fuse element is melting and divided by the actual rating of that fuse. Okay, so of course its value will be more than 1, right? Because if the current rating is 10 ampere, then current if the current will flow more than 10 ampere, then only uh, your fuse will melt. Therefore its ratio will be more than 1. Okay, then prospective current. So here actually we are using some special uh, conductors as the uh, fuse element, right? But if you are using here any other conductor having less resistance, okay, having less resistance, then whatever be the current measured that time when you are replacing that conductor, that current is nothing but the prospective current. So this is the figure which is showing the different terms here. Okay, so here you can see one wave is there. So at this point 0, it is showing that the fault in the circuit is occurred, right? So this is the characteristic of current versus time. Okay, so here at this point 0, the fault is occurred. Okay, fault is occurred. Then uh, this point A, this point A is the cutoff current. Okay, the cutoff current. And here at this point, this is the current 0. Means what actually happens when the fault will occur, when the fault will occur, that time it means that the maximum current is flowing through that fuse. Okay, so when that maximum current will flow through that fuse, that current is flowing through the conductor, through that conductor, and after some time that conductor get melted. Okay, that conductor get melted. So when the conductor melts, okay, that is the cutoff current. Cutoff current means it is the maximum value of current at which your conductor starts melting. And after that, when your conductor will start melting, there will be the production of arc, because immediately these two contacts get separated there, right now. So the arc will be there, and after some time that arc will finish. So it is nothing but the current 0. Means current flowing through the circuit will become 0. So this is called the current 0 point. Okay, so this is there are two parts for this wave. One is the pre-arcing time and second is the arcing time. Okay, means here the arc will uh, is going to produce, and here your arc is present there. Okay, and it starts extinguishing. So this is the total operating time of the fuse. Okay, it is nothing but when fault will occur, that current will flow through the circuit, and then it will start melting that element, and then the arc will be produced, and then the arc will be extinguished. extinguish. So that is the total time. It is divided as a pre-arcing time and arcing time here. Okay. Then these are the unsymmetrical current. Okay. Means you can see here it is not a proper sine wave. Okay. Sine wave is not proper. So it is the unsymmetrical current. Okay. Because the fault is occurred here. Then next is cutoff current. So it is the maximum value of fault current actually reached before the fuse melts. Okay. Then pre-arcing time. So it is the time between commencement of fault until the instant when cutoff occurs. Okay. Means if the fault is occurred and uh, actually that conductor get cut, means disconnected or melted, up to that point is nothing but the pre-arcing time. So you have to just remember this figure. If you remember this, you can easily write the terms there. Okay. You just remember where which term is mentioned here. Okay. From that only you can understand the concept, and also you can write the definitions, right? And if they are asking in MCQs also, from the definition you have to identify that particular term here. Okay. Then these are some more definitions, that is arcing term, arcing time, total operating time, and breaking capacity. Okay. So everyone just remember all the terms here. Then next point here is the characteristics of fuse. So characteristic means there are different current ratings, voltage ratings, breaking capacity, ambient temperature, means that your room temperature, how actually that your fuse is working. Then melting integral I square T rating means it is nothing but when that much current is flowing with that much time. Okay, within what time? That is nothing but the I square RT rating. Then temperature D rating and normal operating current. Okay, so these are the basic characteristics of the fuse. So in examination they are asking as a define uh, a fuse, and they will ask you explain the types of fuses. Okay. And another question on the fuse is define these different terms. Okay. They are asking different terms. Then next is the characteristic of the fuse. So this is the time versus current characteristic. Here the time is in seconds, and it is the prospective short circuit current. Okay. So as the value of current increases, the time required for melting the fuse will decrease. Okay. For the time required for melting the fuse element will decrease as your current will increase. Okay. Then so this is the inverse time characteristic. Remember, this is important characteristic. Okay. Then fuse application. So in many equipments and in distribution purpose also we are using these fuses. So the applications are for protecting transformers, motors, and power system from overcurrent. In feeders, power transformers, solar circuits, then electrical appliances, and house distribution boards for fuse, use fuse for the domestic purposes, right? Then used in automatic cars, electric vehicles, racing cars, rails, etc. Then fuses are present in laptops, hard disk drives, printers, scanners, and electronic devices. and in gaming systems and smartphones. So all these are the applications of fuses. Okay, so all of you remember the applications also. So we know the selected one, but all others you can remember. Then fuse selection. So this fuse is selected by its rated voltage and maximum current rupturing capacity. Okay. Uh, means actually what happens when the maximum current will be there, that time its voltage becomes low, right now, than the rated voltage. So we have to check for that voltage also. And second is maximum current rupturing capacity. Okay, current rupturing capacity means at what mm, current this fuse element starts melting. Okay, then fuse selection. Third is the rated current. Okay, so this rated current is equal to K times sustained maximum load current. Then next is the pickup current. Pickup current means it is the maximum value of the relay coil at which the relay starts. Now from this point, actually your relay is started. Up to the previous point there was a fuse. Okay, now this term is related for the relay. Okay, so we have seen the electromechanical overcurrent relay. In that we have seen this term, that is pickup current. So pickup current means what? For the for electromagnetic relays, we are setting one point. Okay, that is the maximum value of current is set at the relay, so that up to that point, just like the fuse, just like the rating of the fuse, up to that point only your relay will operate under normal working conditions. But if there will be the current flowing beyond that pickup current, then your relay will start operating. Okay, so this is the minimum current in the relay coil at which your relay starts, right, starts operating. Okay, that is the pickup current. Now current setting of electromechanical relays. Okay, so the current setting of relay is nothing but adjusting its pickup value. Okay, uh, means what we are doing here, we have already seen this and perform practical also, right? So there are different knobs. Okay, and this plug is there, and we can put that in any one of the uh, means current value. Okay, so here different ratings are given. Okay, so there you can put that plug or that knob, and you can select the value of the pickup current. So that pickup current is equal to the plug position into rated CT secondary. Okay, suppose that plug position is here 2.5, likewise positions are there 3.75, right, 7.5. uh, so likewise up to 10 the plug positions are there, so you can select any of the plug position and into the rated CT secondary current. Okay, so our transformer CT is of 100 by 5. So it is 5 ampere. It's a rated CT secondary. Uh, sorry, it is 230 by 5. So it is 5 ampere current, right, from the CT secondary. So if you take the 7.5 as plug position and the rated CT secondary current as 5 ampere, then your pickup current is of 37.5 ampere. Okay. Now, if the plug is kept at 5, Okay, means if you keep this plug at 5, then the plug position will become 5, and your rated city secondary current is again 5 ampere. It is constant, right? You are not changing that. So it is again 5. So the total pickup current for this will be 25 ampere. Okay. So in this way, you can set that pickup current. Now, the next point is the plug setting multiplier. So we have seen the different examples on this plug setting multiplier, and next point is the time setting multiplier, right? So for formula for this plug setting multiplier is equal to fault current divided by pickup current. Okay, fault current divided by pickup current, and fault pickup current is equal to plug position into rated city secondary current. Okay, so by using this formula you can find the examples. Also we have seen another examples, right? Then next point is the time setting multiplier. Okay, so you can set the time also just like your plug. There is again one knob, and you can just vary that knob, and the time is changed from 0 to 1 there. Okay, 0 to 1 seconds only here, 0 to 1 seconds. So you can set any time there. Okay, the next is how to find the time of operation of the relay. Okay, so here the characteristic is there, the operating time and the plug setting multiplier. Okay, so if you are getting the plug setting multiplier, so for that uh, uh, the operating time is coming as 3 seconds. Okay, so here you can consider, and according to that you can find the time of operation of the relay by using this formula. Okay, first you have to calculate here the plug setting multiplier and then the operating time here. Okay, then these are some of the examples. So we have already seen these examples. You can I had taken these examples on slate. That's why these are not available in the PowerPoint, but you can see that respective lecture for understanding these examples. And also, if you have noted the examples, then you can refer this. Okay. Then next point is the radial feeders protection. So what is mean by this radial feeder protection? So here we are considering one generating station and one means the line which is supplying to the load. Okay, so this radial feeder protection means what? For this radial feeder protection, there is only one source to supply. Means if the fault will occur, okay, so if the fault will occur, then your whole system will stop there. Okay, so actually here this is the generating station, this is substation 1, substation 2, 3 up to so on, and there are different circuit breakers used for the protection purpose, and these OC1, OC2 and up to OC5, these are the overcurrent relays, right? So we are putting the overcurrent relays also here for the protection purpose. But if the disadvantage is that the fault will occur in the line, your whole system will stop there. Okay, so here what is actually this is the time graded protection for the radial feeders is that here we are specifying the time of operation of the relay. Okay, so uh, the relay which is placed at a far distance from the generating station, it's set at the lowest time, that is nothing but the instantaneous. Then uh, the relays which are near to the generating station will operate at last. Okay, they will operate at last. So first the unit, uh, sorry, first the relay which is far away from the generating station or which is near the fault point will operate first, right now. Then if this relay will fail to operate, okay, suppose the fault is occurred in the system, right, and that time the nearest relay to the fault is nothing but OC5, right now. But if this OC5 will, if this OC5 will fail to operate, that time this OC4 will act there. Okay, and what is the time of operation of OC4? It is 0.5 seconds, right? Means this OC5 will act instantaneously there without checking any other relays whether they are operating or not, right? So it will operate first when the fault will occur. Then the second relay will operate first, that is having the time second of 0.5 seconds. Okay, so the time of operation is delayed by zero point 0.5 seconds for the relay number 4 there. Okay, then next if this relay fails to operate, then the next relay will operate, which is having the operation time, that is 1 second, right? So the overcurrent relay 3 will operate if these both will fail to operate. And again here one more relay is provided which is operating at 1.5 seconds, right? So one by one these relays will operate if the fault will occur in the system there. Okay, समजलंय का? Okay. So this is the radial feeders protection. Then next is the parallel feeders protection. So parallel feeders protection, in this protection we are simply using the two parallel lines. There is a single generating station, but we are using two parallel lines. Means suppose this is your load, the substation is your load, means it is supplying power to the load, right? So what happens if this from the another line the supply is fed to the substation, right? So what happens if the fault will occur in this line? This will get disconnected and the power will be supplied by using this feeder number 2. Okay. So if the fault will occur in feeder 1, then your feeder 2 will operate and it will give the supply there. Okay. So the ring main system now. So in ring main system, what happens actually, if you consider the radial system, in that there is a single generating station, right? But some modifications were done, and which one came? Yes, which one came? The parallel, right? Now parallel feeders came. So in parallel feeders, what we did? So if the one line is failing to operate, the another line will operate there, but the generating station is only one. And if you consider the ring main system protection, in that system, one line is fed by using two generating stations. Okay, one line can be fed by using two generating stations. Okay, so here here you can see the substation is there, distributor and distributors. Okay, so if the fault will occur, so if the fault will occur, so any line and one more line is feeding that line. Okay, that is the ring main system protection. Okay, now the next point is relay coordination. So this is also the important point. What is mean by relay coordination? Anyone? What is mean by this relay coordination? If anybody, what is mean by relay coordination? Yes, anyone? Okay. So here in this relay coordination, what actually happens? Here we are considering one as a generating station. There are different substations, that is substation A, B, C and D. And these substations are supplying some load, right? They are supplying some load. It is just like the your time graded system, right? But what is the difference? Uh, that there are total four substations right now. Four substations, and suppose the fault is occurred at any one of the station, then which one will operate first? Okay, which one will operate first? So there is SS um, D substation. Now this D substation is placed uh, at some longer distance from the generating station, right? So the time of operation, okay, so the time of operation of this of this what we can say, mm, means the time of operation is very less there, means it is instantaneously it will operate. Then if you consider the substation C, uh, that time it is also having some more current than the substation number 2, sorry, D, right? Then if you consider the substation 3, that time, uh, that time uh, its operating time will be more than the substation of C. And if you consider the substation A, it will operate at some maximum level than NSS. Okay, so these are some of the working of the operating system. So so here means here what happens, one by one these relays are operating, means at first your relay at substation 4 should operate first, then for at substation C, then substation B, and then substation A. So the relay should operate uh, sequentially. That's why it is called the relay coordination. It is nothing but the relay coordination. Okay. So if we are considering any one of the fault, then what is the procedure of relay that is shown here? It is same, right? Then the next point here is the overcurrent relay. So what is mean by this overcurrent relay? So this overcurrent relay is nothing but the relay which is operating when the current which is more than the set value of the relay is flowing through the circuit or is flowing through the relay. That time this relay will operate. Okay, that is the overcurrent relay, right? So this overcurrent relay, if you consider the electromechanical relay, so it is having two coils. That is, one is the operating coil and second is the restraining coil, right? So according to that, actually we in last lecture only we have seen the different types of relays, and in that we have seen how actually these electromechanical relays are working. And in these electromechanical relays there are two coils, one is the operating, second is the restraining coil, right? When the current flowing through the operating coil increases, that time only your relay will start operating, right? Otherwise, your restraining current will be more, or the restraining force is more than the operating force, or it is called the deflecting force, right? So, there are different times required for the operation of that relay. So, according to that, there are depending on the time of operation of overcurrent relay. So it can be divided into different types. That is, first is the instantaneous overcurrent relay. Second is definite time overcurrent relay. Third, inverse time overcurrent relay. Then inverse time definite inverse definite minimum time. That is IDMT overcurrent relay. Then very inverse definite time and extremely inverse definite time overcurrent relay. So these are some of the different relays, right? Then we'll see now one by one. This is the instantaneous overcurrent relay. Instantaneous means this relay operates very fastly, means as soon as the fault is occurred, this relay is not taking any time for the operation, for its operation. So if the fault will occur, immediately this relay will sense that fault and it will give signal to the circuit breaker for opening the contacts of faulty section. Okay, so that is your instantaneous overcurrent relay. Okay, then second is definite time overcurrent relay. So definite time means what? We are applying, or we are providing particular time for the operation of relay. For example, if we set the time of 0.5 seconds, right? Then uh, then uh, your relay will start operating after 0.5 seconds only. Means it will sense that fault, but it will actually operate. Okay, it will actually operate at 0.5 seconds. Okay, that is the definite time overcurrent relay. Now, then the third type is inverse time overcurrent relay. Means this is simply your time current characteristic. That is, the as your current will start increasing, your time required for the operation of relay will start decreasing. Okay, means for the higher values of current, your relay will operate immediately, right? So this is your inverse time over current relay. Okay, then Next one is the inverse definite time minimum inverse definite minimum time over current relay. Okay, so this is your IDMT characteristic. So IDMT characteristic means what? Here also we are defining particular time of operation of the relay, and it is approximately equal to the fault current. Okay, it is approximately equal to the fault current. Okay, and this IDMT is used for the protection of distribution line. Okay. Then very inverse definite time over current relay. And next is the extremely inverse definite time over current relay. So these all are the characteristics of the over current relay. Okay. Then next point is the earth fault and phase fault relay. Okay. So we'll see these relays one by one. Uh, earth fault means if for example, the faults like line to ground or double line to ground faults will occur. That time the relays are used for its protection are nothing but the earth fault relays. So here these relays are connected here. For example, if you consider a star connection here, then the neutral wire is there, and here which is connected to the ground. So there your relay will be connected here. Okay, so in this way you can use the earth fault protective scheme or earth fault relay. The next one is the phase fault relays. Means for example, if there are some faults between the lines, okay, or between the phases, that is suppose here L1, L2 and L3 lines are there, and one line is here breaked, or there is a phase loss. Okay, that time this phase fault relay will work. Or suppose the phase sequence get changed here, means any one of the phase uh, uh, get means if you change the sequence, okay, change the sequence of the phases, then also your relay will start working there. Okay, that is phase fault relay. Then there are some advantages of this relay. Next point is the directional relay. So we have seen the directional relays also. Here first type is the induction type directional over current relay. So induction type directional over current relay. So here we are using the double circuit. Right now we are using the double circuit. Here upper part is your directional element, and this lower part is the non-directional element, that is the overcurrent element. So this is for the normal operating condition. Okay, this is for the normal operating condition. But when the overcurrent or very high current will flow through the circuit, that time this will operate. Okay, this part will start operating, means the current will flow through this circuit. Okay, so it is the induction type directional over current relay. So there are two types, directional and non-directional. Directional means current that fault current is flowing in only one direction. Okay, means if the fault is occurred, that current is flowing in only one direction. That is nothing but the directional over current relay. And when the fault will occur, uh, when the current will flow in both directions, okay, in both directions, that is called the non-directional relay, or it is the non-directional element. Okay, so next point is static relays. So static means constant. Yesterday only we have seen these static relays, right? So there are also different characteristics for this static relay, and this is the block diagram of our static relay. So input current, input transformer is there. This is instantaneous over current relay. Uh, Input current, input transformer, rectifier, filter, then level detector, amplifier, and output device. Okay. So in this level detector, all your operations are done. Okay, means actually the comparison will be done there. Means what is the actual value of the current which should flow through the circuit, and what is the fault current. So that will be compared in this level detector. Okay, and then that is amplified, and the output signal is given as a trip signal. Okay, so this is instantaneous over current relay. Next is the definite time over current release. So these all are for the static relays. Then microprocessor based over current release. So in yesterday's lecture only we have seen this microprocessor based over current release. Now mm, actually we have seen the microprocessor based over current relay also, right? Na? Right? A static relay. We have seen only the explanation for that chapter, for that practical, right? And we are going to conduct the experiment on that also. Okay. So it is having some disadvantages. That's why it is not used for the practical purpose mostly. Okay. Nowadays, we are using the numerical over current relays. Okay. But that experiment or that is only for your study purpose. Okay. So here, same cities are there: I to V converter, rectifier, multiplexer, A to D converter, then port A uh, for the microprocessor, uh, port C, port B, okay, upper part, lower part of the ports. Okay, so and when the fault will occur, this processor will do the operation and it will give the signal to the circuit breaker. Okay, so these are the microprocessor based relays, and the advantages are it is programmable. Microprocessor based relays are programmable, and they can do the online calculations. Okay. Then next is the numerical overcurrent relay. So this is important one, numerical overcurrent relay, right? It is having advantages as very fast and accurate. They are more flexible and used for selective short circuit and earth fault protection of radial feeders, right? So we are using this numerical over current release. So we have seen the experiment of that, and we performed and we have seen the characteristic also. So it takes very less time than the electromechanical relay for its operation when the fault will occur. So it again includes the current transformer or potential transformer, then signal conditioners, then sample and hold circuit, analog multiplexer, AYD converter, then processor is there. And after processing, it is giving signal to the circuit breaker. Okay. So these are the numerical overcurrent relays. Then differential relays. So differential relays means when some of the difference of current or voltage will flow through the relays, then uh, uh, through the coil, then your relay will operate. That is nothing but the differential relay. So you can use this differential protection or differential relays for the protection of different equipments. Okay. These are the differential relays. And last point is the line protection. Okay, means we have to protect the transmission line. So for the protection of the line, we are using the time graded overcurrent protection system, and differential protection, and the distance protection. Because when we are protecting the line, it does not include only the transmission line, but it includes all other elements also, right? So we have to protect that line. So for that protection, we are using this time graded protection, differential protection, and distance protection, right? Also, we are using the backup protection, okay, for the protection of the lines there. Okay, so uh, this was the overview of our second chapter, right? So in this way, we reviewed our second chapter also. So there are some MCQs which are given in Drive. So you can refer these MCQs also, and you are having tests, right? So for each chapter, there are minimum 20 questions. So if you do these questions at least, then you will come to know the which types of questions are asked in examination. Okay. So the exam dates are already came, so you can prepare for the same. Okay. So for today, we'll end now. Thank you all and have a nice day. Thank you.